How's your week? Same what? Hmm? How's your week? My camera is not necessary. Ananya, can you hear me?
Yes, sir.
Okay. Bella. Yeah. Not a view. So when I look at your book, right, I mean, people start your book. What are you sure your return possible? Yeah. Well, LMP makes sense. LMG, is it
No,
tension?
that.
Okay. So, yes, I got what you said. Yeah, we are going to do that again class because last class everybody got quite saturated, right? So we'll do that again. But did you do the 2, 3 equations? Did it? You got the answer? The lesson set is right. But you got okay, that's all. And there's no doubt regarding this. The concept is clear, I think, right? Okay, so we will redo that thing from last class. Okay, we're going to redo that again, and I'm going to teach you some concepts uh, involved in this in our episode. So there's a concept of see the idea. One of the ideas that we're going to use for this is that if I have a physical quantity on the LHS, let's say some quantity called H. Okay, and this H is has the power X. All right, and it's equal to let's say M H Y plus 2. So the idea is that when I have a similar quantity on the LHS and the RHS on both sides, I can equate their powers. So I can say equating powers of H. Okay, what will it be? X is equal to 5 plus 2. Understood? Because the same quantity is on both sides, their powers I can say that they're equal. Or I can say if let's say we had m raised to x are here, because we already have one x, it's not x. If I have m raised to or let's say x only, if I have m raised to x are here, what will x be equal to if I equate the powers of m? What will it be equal to? X will be equal to correct. Because on the other side, we don't have and the same thing. Okay. You getting it? They're equating the power to the same particle, isn't it? So is it? So after we got really like didn't understand what happened. Okay. When are we interested in the for? If you have a doubt, the plan is letting clear. Okay. No, you did this problem. You got the answer. The LHS is equal to RHS, we got that thing. Ananya, were you able to solve this problem that was given in the last year? Okay. Yes. Good. Wonderful. And we were starting off something, but remember that you guys are all saturated, so we thought we'll start it in this class. And I told you I'll teach you in detail. Yes. So the idea is this again, that when I have an equation, there's a right, that if I have some quantity of both sides, let's say H I'm having both sides, H is and some value is power. And the powers of the same power. Okay, and if there is an equity power X is equal to 5 plus 2, I can do that. Okay, now if I'm equating the powers of M, having a just that of I so what is equal to? This is clear. Follow the concept and then we do the doubt solving. Now this is that I mean the reason I'm introducing this is yeah. See, using physical quantities, we can derive some equations or we can do some derivations. And we can check if the derivation you are correct or not. For example, last time what you guys did is you guys had some equations that we gave last time, and we checked if the LHS is equal to RHS. Let's say you have some scientist, and you want to check if this equation is correct. One of the ways that checking if it is correct is to check if it is dimensionally correct. So the dimensions on this side are matching with the dimensions on this side. So it will let you give you an idea that the dimensionally the equation is correct. Because why? Because why do you have to check this? Because you come up with some new equation. You have no way, let's say, checking it, testing. So this becomes one of the ways to do it. Okay? Fine. So what we did was we said that we can derive some equations, right? We can derive some equations using the and the example that is given is now, for example, I have a simple pendulum. Okay, this is my pendulum. Okay, and I want to check the time period of the pendulum T. That's where your T comes from. Okay, so what I can do is I look at what rate time is right? So I can say the time period is proportional to the length of the string, correct? Fine. I can say the time period is proportional to the mass which is attached at the end of the string of the pendulum. And I can say that the time period is also proportional to my gravity. And so this is where this came from. Right. So D is directly proportional to L and G. I can write it like this. But it is not equal to, it is proportional. So whenever we have to change from proportionality to making it equal to, there is a constant of proportionality to that. Okay? Simple. The idea is that you know you are about it. If this is business, this increases, or if this increases, this increases. But that doesn't mean increasing in equal part. Just means there's a so we have to multiply by some value which tells you by how much the increase or decrease is happening. Okay. So I put in a constant of proportionality k, and I say this is it's. But the thing is again, let me say I'm going to write it like this. Can anyone tell me why?
Because not being that all the three values should be these can be
Okay.
we can raise this power to you.
Very nice. That is one of the things. The idea is basically this. I know that this is increasing. And G are increasing. But I don't know by how much again. See, I can put a constant of proportionality, but that could mean that T is proportional to L square. It could in this, or it could mean that T is proportional to L cube. It's I know it's proportional to L, but by how much? It could be L times L, it could be L times L, or whatever. So what I mean is I put X, Y, and Z. And X, Y, and Z can also be 0. And can be any value. Is this clear? Okay. This is going to I'm just starting like this. I'm going to solve it now. That's when you get what have we done? Okay. When I solve it, we will get more a clearer idea. So now you guys know the dimensions of T time in terms of M, L, and T. What is time going to be? So what is it in terms of M, L, and T? M to the power 0, L to the power 0, T to the power 1. Excellent. Okay. 1. K, I don't have a system. And do you know what is length going to be? Is to the power 0. It's whole to the power x. Okay. Now, what is M going to be?
N to the power 1.
And what is my G going to be? You have done this for acceleration last class. You can check it. You can go to me now. Example is meter per second square. Yeah. Can you remember meter per second square? That makes it. That's what this unit is. So now what I want you to do is write this down. You can write from the pendulum only. You can kind of make notes in a way that this one and come to here. Okay. You can note these things down in a way that you understand. But there's a problem. Yeah, I have written that okay, can be there. It's just a point and not a part of this. You know that, no? It's not exactly giving you the idea that it could be elsewhere or then two for it. It is not part of Yeah. So if you've written this, we can go forward. Okay. So now what I want you to do is, I want you to put all the N, all the L, and all the B's together. Does that make sense?
Yes.
Yeah.
Because we are not saying that
Yeah. What? What? What?
we are not saying right now.
So I want you to see and power this thing. The power thing. That doesn't mean it will be and it will become. What? That's what. You got it, buddy? Yeah. Ananya, you got what I'm trying to say?
Yes, sir.
Okay. Can you equate the powers of M first? And then you're gonna write equating the powers of L. Then you're gonna equate the powers of. Yeah. Ananya, were you able to get the result that I've written?
Sir, I have a doubt in what you wrote.
Yeah, please tell me.
Is that 27 or 7? Is it 27 or
Sorry,
Z?
minus 2Z. This one, no? The one I just erased. E to the power, right?
Yes, sir.
Minus 2Z it will be.
2Z?
Yeah, Z. X, Y, Z wala. Okay. So, can you simplify and find the, there is one.
So after getting this, we find for X, Y, and Z.
Yeah, yeah, that's exactly what I told, right? You have made, what did you say?
First, I got body is.
Okay. So, yeah. Okay.
Then equal to minus six, negative equal to minus seven. So yes,
What are you getting it? Because of the check. You understand what this is? No. So now we. I want you to tell me, first I want to equate the powers of M, and do the same. Do the same with the L, and do the same with T. Okay. All right. Can we do this?
That is then equal to 1 minus 1 by 2.
Correct. Okay. So what will you get? Y is equal to 0 with your first one. And the
Plus and into
okay, tell me the equation. X plus z equal to 0. Last one is
2 minus
z equals 1. So can I solve this? And if I solve this, the last one I can write this, right? I can write z is equal to minus 1 by 2. Okay. So now if I have z is equal to minus 1 by 2, I can put this equation in here, and what I'll get?
x is equal to 1.
X plus which implies that x equal to 1 by 2 and y is equal to 0. Okay. So these are my three values. Awesome. So now what I want you to do is everyone here, Ananya, have we reached this point where we have found x, y, and z?
Yes, sir.
Have you been able to understand what I'm doing?
Yes, sir.
Okay. So can you put this values in a first equation where we write E in terms of k, l, x, m, y, and b to the power. Put the values of x and z. Now at the end, last you write E equal to. Okay. So can somebody tell me what this is? No, okay, then do it for a bit. Then we put the. You guys do it, try to arrive at the answer by yourself. Okay.
The elaboration means like we need to write T that is proportional to L to the power of 8.
I think yeah. I think it is. You've done it right. Got it right? Absolutely. Yeah, direct substitution. Amazing. So what is the equation? Please tell me. K and then L 1 by 2. 1 by L for 1 by 2. Okay. M to the power 0. E of the point minus 1 by 2. Okay. So my M term will not exist because it is to the power 0 will be equal to 1. So anything raised to the power 0 is 1. Amazing. So my L will be what? What is L to the power of 1 by 2? Basically, root of L. You understood? You know this, right? Okay. And G to the power 1 by 2 is basically 1. It's not 1. So basically, K root of L by G. So in this way, we have been able to derive the time period of a pendulum. Okay, in this way, isn't this interesting? 1 minute, I'll explain this. Okay. So, isn't it interesting, first of all, that using just the dimensional analysis, and see, first we found one, we observe quantity. We said, if I take a pendulum and I have the time, I want to check its time period, how will I do that? Using no experiment. Imagine this. You did just sat on your table, the book and the pencil, and you were to just in the help of your economy, okay, marks, it will be proportional to the length of the string, it will be proportional to gravity, and just that imagination, a book and a pencil, you will be able to derive the time period of a pendulum. With I will keep nothing. So, you follow this. We can actually calculate it, we can take the length of the string, we can keep changing length, we can find calculate it, and you can also measure the time. So it will match. You get the idea. So if I take the pendulum, let's take one particular length, let's say 50 centimeters, and I'm going to take of and so measure the time. It may come 1.25 seconds, let's say. This value is needed aside. If I measure now, okay, this is also come on. Okay, getting the idea, and very extremely, we have our own design for the not that the spot mark weight in your but is the weight actually playing in your road or not? It's not. So even if you consider a wrong variable, you tell, oh, it may be proportional to the color of the pendulum. You think you will tell, but what will happen when you do dimension come to zero? Doesn't make sense and it is not proper. Isn't that something very cool? Don't you think we can appreciate how cool this concept is? Right? So the K loop it is just a constant. And this constant values have to be found out, right? Okay? And it will not be right. And this you can do. You know that if you measure one then you can do experiment. One experiment. Why
Yeah.
Let's say I need to time only one day, but I no. Shorter, longer, that is called a constant because it's constant always. Okay. She has been forward. She will move. She will just like you know, five, what's five? Five one, 5, 9, 2, 5, 5, so on. So yeah. So that way that they are constants with values we should know. All right. Fine. So, but even with so many beautiful advantages and beautiful applications, there are few limitations of dimensional analysis, and that's always the case. Anything is not only there are going to be some limitations, and that's why what we always will be used to search to do something right. Because if something has one that limitation, some other will have a different limitation, so it will be compensated. Okay. Your strengths and weaknesses will. That's why even in companies they always hire a team to do something. Because if I'm not good at something, somebody else will do it. So what are these limitations? The first one says to derive a physical quantity, if you see the reason we were able to do the last exercise is because we knew what are the factors the time period depends on. If you don't, if you imagine some quantity, you don't know what are the factors, then will you be able to do this human being? Okay, that's quite simple, it's common sense, right? Yeah, and then yeah, the value of the constant could be figure it out. He was able to do it. He was very able to figure it out. Using this method only you are not able to do that. This method is not giving okay. So again, so that is one thing. That my constant value is not telling me. Okay. This method may be fruitful only when the number of constants is exactly known, is same as the number of equations in order to determine them. So the idea is basically this: how many, if you have one unknown, how many equations do you need to solve to find one unknown? Let's say I want to find what is x. Okay, how many equations do I need to know? I need to know minimum two to say, but actually one, because there's only x. So it will be either 2 plus x is equal to 0, because only x is there. So what will be x? X will be minus 2. So if I have one unknown, one equation is enough for me. If I have two unknowns, x and y, it will be what? Let's say 2x plus y is equal to 7. And let's say I have 0 plus y is equal to 3 or something. Okay, that doesn't make sense, but okay, you get the idea, right? Or whatever. So I need at least two equations to solve this. That is the idea. So similarly, this method is fruitful only when the number of unknown constants is exactly equal to the number of equations. So earlier we had basically another thing is if we know of the constants there are, and we assume what is the here? But let's say we have forgotten what would happen? You get some constant and root n. And that constant g and this constant would be known as the single number. You're getting my idea? You're getting the point? So that is one of the things, okay? And if there are more number of constants, we will need more equations for them. That is the problem. Okay? Fine. And by this method, we cannot establish the half. This method cannot be used for any kind of equation that involves trigonometry equation. But tan, sine, not used to that. Because we need dimension. And here, there is not but your equation might have. But will this consider that? Simple. If you understand and study, all of this is very simple to remember. Okay? Understanding is easy. You guys have to remember this. So with this, congratulations. We come to the end of our unit for unit summation. That's it. I have made it look that it. I have made it very easy. So that is when you study, have you studied this?
Yeah, today I didn't get happening.
But did you go through the whole thing? But the unit is the thing is we simplify things very easily and you guys have to go back and do it. Because quite honestly, for your level, there might be quite a problem. Okay, but we make it easy. Easily it's coming in, easy people will go out also, study properly. Okay, so with this we come to an end, but before we may end, maybe what I can do is I want you to, let's see, if you have time to then we'll do it again. But there is one question called on the basis of this only. There's a question illustration in your textbook, illustration number 8. Don't open it now. I want you to do this at home. And if you have a doubt, there's an idea of tension, write it down, tension, which is nothing but force, okay? Force
So, repeat the question.
into 1 minute. No, the question is that what I've said is that there's illustration number 8 in your book that you guys can do at home. You guys can try it at home. And you guys can come to me in the next class. That's what I said. Okay. 1 minute. I think I should check something out before I give this to you. You force into. Okay, I'm not sure about this. Find out what the. I have done it, but I could cross verify. Find out what tension is. Okay. You'll have to find that out for your for this question. Okay, tension will be either it just do it and you find out that is the best thing.
The way
Illustration is that's enough for page number 20. Okay. Okay. So then see, if you have your books now, go to page number 21. Page number 21 of this book. Everybody can turn the pages. Ananya, you can also go to page number 21. Okay. Or I think it's called page number. No, okay, we have a different numbering system. So they have not done. Okay, you don't have what I have. We have this concept map thing. What page number? What page is it on? 10. Okay, then page number 10. Go to page number 10. Okay. So can you go through it? So in the middle, it's the have we discussed what fundamental units are? Yes. Derived units? Yes. Supplementary units? You can read this. I don't want to confuse you then. It's a very simple concept. Okay? Like, okay. I believe we have done supplementary units, but if not, it should be there should be just one line or two of it. Something along those lines. But the thing is, you guys are already confused and I don't want to take it one step further. But it's just 2 lines of it. Nothing that you cannot read and. So then, if we look into okay, it starts in the middle units and measurements. You see that, right? So from there, if you go up unit, we have defined. We have looked at types of units, and then we go to the side property of units. We have seen. We've seen the system of units. We have defined accuracy and precision. We have done. Then we have looked at different types of different systems of units, SI unit, and all the various different types of units. Then we have looked into errors. We have looked at types of errors, relative error, absolute error, percentage error, all of this. We have looked at how to what is the form, what is error? It's true value minus measured value, right? And then we have looked at how to deal with the combination of errors when they are added or when they are subtracted. Then we have looked at multiplication and division of errors. We have looked at measured quantity raised by powers when there are errors and they involve powers. Then we go to the side and we can see significant figures, and we had a discussion on significant figures. We have had a discussion on dimensions, and then we looked at dimensions and we saw the application of dimensions and how we can use it. And at the end we ended with the limitation. Is that much clear to you?
So what is limitation?
The last thing we did was limitation. Just now we talked about the limitations of error. Not error, limitations of what is the thing, dimensional analysis. Last thing we did was like dimensional analysis. That's okay.
No, but then
Last thing we talked. Okay. So as you can see, if you turn around the pages, you will see a lot of questions. Correct? And physically, and this might be irritating to you, but the problem is that physically we cannot solve all of these questions in the class. But what I can do in class is I can give you the base and the understanding of the concept, which will prepare you to solve any problem and make it quite easy. Okay. So my job here is to give you the conceptual understanding of things. Your job is to solve the problem. If you think whatever I'm teaching is all that exists, then you're going to be okay. If you say, okay, I'll study what the has taught only, and then you realize that you're in trouble because this is what I'm giving you is conceptual things. Okay, but are you satisfied with this way of teaching? Is that fine? Is that okay with you? Ananya, is that okay with you?
Yes.
Okay. Yeah, tell me. The thing is, I did not. Which book are you talking about? Me, your textbook is it? Okay, can you have it with you? And take a look at it. Even I wanted to do a few problems in parallel error, but the problem was that it did not have a lot of like the example. Yeah. That should be. Okay, so this we have discussed. Okay. And we have done two problems. Okay. Can we do this in the next class? Is that fine? Yes. Because I want to first go through it. But it's quite easy as far as because what parallel error is, we just have one equation. It's all you have. Okay. The idea is there is one relation alpha is equal to small d by capital D. Alpha is the angular, it's called the angular size of planet or something. Okay. D will be the diameter of planet. Okay. And capital D will be the distance between the literally this is about it. This is all you. So by using this one equation we can solve. Yeah, see 1 minute. See, if you look at the first question that you showed me, calculate the angle. Okay, see example 2.1 that you have in the book. This is nothing to do with parallax. Okay, I'll tell you what it has to do. Okay, a man wishes to estimate the distance of a nearby tower. Okay.
Well, doesn't need to reduce the accuracy by having
1 minute. Man wishes to estimate the distance of a nearby tower. That's the point A. In front of the tower, C is for the distance because of the distance and that is same. So we have a parallax angle with that. Hebrew, these are like very simple sums. You know what tan is, right?
Yeah, so only trigonometry is.
Yeah. See, they are not even, they are barely even related to your this thing. So, blah, 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 blah. Okay, see, there is something, something. Yeah, that's all. Okay. In your textbook, example 2.1. Example 2.1, calculate the angle of 1 degree now in radians. Okay. So this is the first question. Do you guys know what radians is? So there's a different type of unit of measurement. I assume you know math, they should do this for you. Math, okay. So the concept is quite simple. Okay. You know how we convert centigrade and Fahrenheit? Okay. There are two different measurement units of measurement for temperature. Two different units for temperature. Similarly, for degrees, we have two units of measurements. One is degrees only. Okay. Another one is something called radians. Is that okay? It's called radians. And generally, for any kind of calculation, we use speed. Okay, because radians thing is degree, no, something as the value has something degree, like 30 degrees. Understood? It will be the value is 30 degrees or something. I cannot use that value for direct multiplication and calculation. For example, if I have a value and I have something as I have to multiply length and angle. Multiply length and angle, it doesn't make sense. There are two different types of quantities. So we convert into something called you will understand something called radians. Because in radians I have a number. For example, if I want to multiply something, a number with something, which one seems like a more multipliable figure? This seems like a 1.41 seems like a proper number. This seems like a 50. It's a you're getting it. It's slightly different. But 1.416 and all of that when I'm getting, it makes sense because I can multiply it, I can do something. We can equate it. So we need radians scientifically for anything, and the conversion is very good. It's very easy for us. Get it? If I know value in degrees, I can directly convert to degrees. How do we convert? I tell you now. Okay, you know this. You know your Cartesian plane. See, this explanation is not there in your textbook. This is my explanation in order to make you understand it. And this is the truth. If you want to, you can write it because this explanation you will not find anything. This is for your okay. But this is not a part of your syllabus. I am only explaining this to you because you have asked. Clear? So do you know what is how much is this degree? This is called 180 degrees. And the thing is, radians I can write in terms of pi. Pi are 22 by 7, 1.14, 1.965, on. Okay. So this is 180 degree, right? Now 180 degree is going to be equal to pi. Okay. Do you guys know this kind of thing? You have studied this in math. Okay. Where have you come across this anywhere? If you are not, still you are not, right? So this is equal to pi. That's all you need to do. This is allowed. So what is this in degrees? 360. In terms of pi, what will it be? That's all. So if I have this, what is this going to be? It's going to be 90. What will it be? 5 by 2. That's all. So what is in degrees? What in radians is 5 by 2. Okay. In degrees, what is 1 degree? 5. Or that will be the value. In degrees, what is 360? 5. Is that much clear to you? 1 degree, 5 degree. That's all. Okay. Is this much clear to you? So what you can do is, if you have a value x in degrees, and I want to convert it into radians, I multiply by pi and I divide by 180 degrees. That's all, remember. Okay? This is not a part of the syllabus.
Right, then I will.
So the idea is quite simple, man. It's very. If I have 9, so what is it? Oh, fine. Let me say this way. What is 180 degree? Fine. So 5 by 180 degree means 185 degree. Then
We need to calculate.
in degree. Five. So how many 5? That's all. That's an easy way to do it. You getting it right? Okay. So this is so your first question, no? And one thing is, see, some things maybe I have not. If you did a good thing, you asked me a doubt. You guys always go back, go through the stuff. If you feel there's something I have not explained sufficiently, or something I have maybe skipped, you can always come back and you can ask me. But sometimes what I do is some things, if I find it very that okay, you can read and done and we don't go into the detail of it. Okay? Or sometimes I think I will give the demo. See, I found out just now that you guys have no idea about gradients and degrees. Okay, my mind like that you would have done. And then you will go minutes, degrees, seconds. In 1 hour, how many minutes are there? In 1 minute, how many seconds are there? 60 seconds. Okay, good. So, so 1 degree, 1 degree is the law, it can be broken into 60 units, and each of them is called a minute. Okay, it's good. Note denoted by 1 dash, and 1 minute can be broken down into 60 seconds. This is not time. This is a unit of degrees. It is just called the same thing. Listen. I have 1 degree. I want to measure something which is more half a degree. I need some big I'm ready from 60 bar and I want to see 1 minute. The need is not, but the need is not. Is that how it's going? It's just so, so 1 minute is a 60. That's all. Is it clear to you? Not overlapping. It's a different that how that this 1 minute is called. Is this clear to you? Ananya, is this clear to you? Yeah.
Yes.
See, some of this stuff is, but it's a very simple concept, right?
So the same, this is 1 dash, so this again one also 1 dash.
Yeah, one time. The dash is called how many?
So there will be some problems from the we can do like
You want to which area? Dimensional or you want to
Dimensional and
because okay, the thing is, there's something you can do, but I mean, so there's one more thing I want. You can solve this very problem, but it may take a while because you may need to see in this problem what they've done is they said we saw how to convert degrees into radians. So if I want to convert 1 degree into radians, what is it going to be? Pi into pi by 180. So I'm going to get some value. Some no, it won't be one. It will be in terms of 5 to 3.175. So you subtract that value. Okay. Is the dimension that will be quantity. So they mean the thing. Okay. So you solve this, you get a particular value. Now, if you want to convert something in radians, if we write it like this, okay, radians. Fine. Now you want to convert 1 minute into radians. What you can simply do is you can divide this value divided by 60. If you want to find what is 1 second, this value you get again you divide by that's all. Okay, is that clear? The second question is simply our trigonometry, which is quite easy. The third problem is a very direct substitution of this equation that we have to see. Remember our listing planets and all I did all that dance and all I did. Some idea. This is the equation that we get. Okay. So using this equation very directly, it's direct. This is not directly. That's why I don't. I'm not called it. Yeah. But, so from that Which one?
You gave the assignment idea.
Mhm.
From the
Let us check it out. Okay, but yeah, it doesn't,
like after that,
there's not this, we have to keep it.
practice
It's not the end, is it?
practice on
Practice. One of the practice. Practice exercises one. We have to give it.
what's that.
Okay.
So those white issues are come back to shift at ground, so they are saying
Those vibrations are used to, in fact, you have to what is. For that, we need to walk. So that walk, electricity will be performed. Understand we start early. And that vibration, and you need to uh, so, I can maybe I will one that I define my one five and from what this is. You get it? But I need what somehow for me. So that I this area is uh, the creator of yeah. Okay.
Yeah, sir, mention of liquid.
Yeah, some questions are quite complex. I don't know why they are uh, confusing you guys, but whatever you can solve, you solve. We'll discuss in the next class. Okay. Some of these things may be quite complex for you. You focus on dimensional analysis mainly. You focus on if there is an equation that is not known, like surface, what surface tension, what you're talking about, right? Then you try to find out from Google or somewhere, and you try to put those the dimensions of that, and you try to solve it. Okay. Otherwise, the main idea is that you should know how to do dimension. Not that you should know all these equations. It may not be possible for you to learn all these equations. And maybe I believe in exams or something in this, if they give you such equation, they mention surface tension or they mention such thing, they will probably give you the equation of that so that you can write what it is it in terms of its dimensional quantity. Okay, is that clear? Okay. Is that clear, Ananya? Ananya, can you hear me?
Yes, sir.
Okay, but if you have any doubts, you can always talk, you put it in the group, then you can, I will have you in the group and you will see. Me and Ananya have been there, me and Ananya, this guy has been, we have been in the group for 1 week and there's no text, I don't know where is the, yeah, okay, talk me a text, I'll add it. Fine, let him come back. And on that note, we will go to the next class, the next topic. All of this is clear, no?
Yeah. What is this?
My God, why do they such market?
No, I mean,
My FLA and I. Okay. Viscosity is basically a measure of how much a liquid can flow. So if I take a liquid, I can describe it in terms of multiple layers. Layer 1, 2, 3, 4, 5, 6, and 8. Each of these layers experience friction with one another. So if you see, if I pour this liquid like this, pour it down, the top layer will first try to flow. This layer will pull the second layer. This layer will pull this layer because of friction. Okay. If you see water and honey, which one will flow easily? Water flows easily because of the same.
because it's like, is it related to density?
Yes. Okay. All right, is that clear? Okay, I'll move to the next unit now. I can move now. I have your permission. So we'll look into the second unit. It's called motion in a straight line. And guys, if you have any doubt, take a picture of the question or the problem, put it in the group. If you have something you did not understand, you can text in the group. That's what the group will be for. It's not possible to do everything in 3 hours per week. It's not possible. Okay? Whatever is necessary for you to understand, I'll teach it to you. Beyond that, that effort you have to put. Okay? And I don't want anybody without even trying to understand how to solve an answer coming and asking me questions. If there's a question, you first try it. If you can understand it, good, right? But you're not even, if you're not, without making an attempt, if you come back with questions, then it looks like you're not even tried it. You just read the question and you have given up. Don't do that. Try to solve. If you fail, that's fine. Then we can solve it together. We can figure it out. But try it. Okay, give a genuine attempt. Okay, fine. So, what is rest? Something is not moving. Amazing. How do you know it's not moving?
Because again, there is no force activity.
No. Good answer. Good.
Respect to the moving object.
Good. So can you think in that way and come up with some idea? In according to their how they're saying their thought process. What do you think?
Yeah.
So he said it's stationary. He's saying with the respect to some moving object, it is stationary. What would you say?
With respect to reason, the other things are.
With the respect to its okay, fine. So, but I want you to understand one thing. Okay. And then what is motion then? How would you describe motion? No, I wanted to terms of the same thing. How you said, how you describe this? Huh? Okay, good. No, we are not talking about force. We are just talking about motion. Any object which is moving. Okay, fine. Okay, fine. So, the thing is, you guys made some very, how did we describe rest? You said something. Okay, fine. What did you say? Rest? Yes, fine. So, with respect to, he used the term with respect to. So, the idea is that for you to know something is stationary, compare it with something else. Meaning, if there's a pen, and how do I know it is stationary? With respect to its surroundings, it is not in motion. And with time, it is not changing. Correct? Fine. How do I know something is moving? With respect to its surroundings, it is in motion. And with time, its position is changing. Not the same. Not constant. Is that clear? Fine. So now we are going to go deeper into this idea and we are going to look further into this idea and we are going to see that. So if you want to describe motion or rest, you need something called, okay, we are going to go into this. Fine. Let's say there is one. There's an airplane. I'll draw an airplane. Or a train. Train would be better. This is my train, okay? Don't judge. It's a bullet train. Fine. And these are the windows. And there's a man. Is inside, half of his body is inside. Okay. Man goes from point A, he is sitting in the back seat. He's going to the front seat. To B. Okay. Now you can see this person from the side. Okay. So what do you see? Is it moving? He goes from A to B. From here can you see? You are seeing it. Okay, as you are standing screen, right? As you are on the side. Let's say you are in a car next to the bullet train. So you are seeing this. Will you say it is in motion? Correct? It is in motion. Is it stationary? No. Now, let's say you are okay. or the better way would be, so is the train moving? Let's do the same thing with a different example which makes more sense. Okay. So let's say there's a train, now the train itself is going, okay, and you are standing out here and you're looking at the train. The train is in position A. Forgive me, my train is ugly. Okay, it goes to position B. Okay. So you're this person out here. This is you. So from here you're seeing it go from A to B. So is it in motion? It is in motion. It's not stationary. Now let's say you will change your position. You're standing in front of the train. Is the train stationary or is it in? You look at the train. It's coming towards you. Is it stationary or is it in motion? It is in motion. But what you will see is you'll see the front of the train. Forgive me for my bad drawing. Okay. The train, the front side, whatever you see. So you will see the front of the train. And with respect to your x and y axis, will its position change? No. It will just come like this. According to the x-axis, according to the y-axis and x-axis, the train is coming towards you. You're standing at here, okay? You're staring at it. According to the x-axis, it will remain there only. According to the y-axis, also, it's not going up, right?
Okay, not the changing it in that.
No, it's not changing its direction. It's coming straight. So according to x and y-axis, it is on x and y-axis. This position does not change. So it's stationary with respect to where we are looking from. But here, if I were to draw this plane, is it changing along y-axis? Huh? Yes, sir. Along y-axis, is it height going up and down? Is the train jumping up and down? No. But along x-axis, is it changing? Yes. So what is changed? Correct? Everybody is on board? Everybody understands this? So what is changing is my frame of reference. Okay, as a game designer, this is going to be one of your most important things. Your frame of reference. Okay. So you're getting it. So anything that is described, we describe it with one frame of reference. Okay. All right. Is everybody clear about this? Fine. And if the size of an object is smaller than the distance moved by it in a fixed interval of time, it is called a point object. Basically, if the amount of change in its position, let's say the train is coming like this, it's coming towards you. Okay, like what I give some ugly train will draw. Let me draw it like a box this time. Okay. These are the wheels. Along its x and y axis, the amount of change is very small over a period of time. It's coming towards you. It's coming like this. Along y axis is it changing? No. Along x axis is it changing? No. So its change is very little with the passage of time. This is called a point object. Okay. It's called a point object. That's all you should remember. Okay. So and this case here along y-axis, was it changing? Was the train changing? No, the train is not jumping up and down. But along x-axis it is changing. So this is called motion in a straight line or motion in one dimension. All right. With time, its motion is changing, but only with respect to one coordinate. Yeah, tell me.
We aim to be both these sides.
Yeah.
We have motion in the same way, but not for the thing which you see in the front of you.
Yeah. So what happens is as per your frame of reference, it changes.
The motion.
So for this frame of reference, it's one dimensional motion. For that frame of reference, you could say it is stationary. All right. Is that good? Yeah. Everything has to be described in multiple frames of reference. The thing is, our eye, it will not see like this only. When something is coming towards me, also I have a vision which is quite profound. So I know that it is coming towards me. Otherwise, you would not. Is that good? That, fine. We see three-dimensional vision. We don't see two-dimensionally.
So, the same thing that.
Yes.
If we see it from above, we see the drone side view. Like, we are seeing the window and the upper part at the same time, like in the angle we are seeing. So, would we call that motion at two dimensions?
Draw it for me. I'm not able to understand where is your drone and from where it is seen. We don't have time for all this, my child. There's a lot to do. Draw it for me. No, it doesn't work like that. You have to draw it on the phone. Find out what is happening. Okay. For example, okay, yeah. This is okay. So that is what the tree now.
Yeah.
Okay.
So, this is the top part
Okay.
and this is the window part.
Yes.
So, suppose we are observing it from this side and like it's moving.
Okay.
It's moving towards this side. So here we are seeing like two angles, right? Like two positions, two point of views. So will we say that this is two-dimensional motion?
See, first of all, this two-dimensional. Okay. Because what you will do is, if you see it flat also, go back. If you see it flat also, you'll say draw two axes. That's all you're going to. Okay. So is it changing along x-axis? Is it changing along y-axis? Yes, I mean it least planned. So I'm assuming it is going like this. If it is planned, then along y-axis also it will change. You will hear it from. See, there is a change along y-axis also. And there is a change along x-axis also. So there is a two-dimensional change. Okay.
So it doesn't match what the reality.
You're doing those two things. That's all. From whichever view. Okay. And there's going to be a z-axis. Z-axis generally refers to depth. Right, z are here. Okay. It refers to depth. Good. So everything we do in terms of 3 x, y, z or z. Okay. Fine. So now, what is? Do you know what is the difference between distance and displacement? Tell me. Distance is the overall distance. You're right. Tell me in proper words. Okay, let's say I will take this one. Okay, there is a. This is my B.
Distance is equal to speed into time, whereas displacement is speed into time with regard to direction.
It's speed into time with regard to time. So what? So this is one part. Tell me. So there are two lines. So distance is the total length from A to B, you could say. So whatever path you want to, like the solid line are here. Let's say this is the path I took from A to B. So I walked round and round in circles. So my distance is going to be the total distance, the total length that I've traveled along that path. I could have gone in circles, I could have gone whatever. Finally, I reached B. Displacement is the dotted line. That is the shortest distance between two points. Okay? Can your distance be equal to displacement?
So you can.
It can be. If I walk in a straight line, then my distance and displacement same thing.
Like, walk to the dot line, to spin to the. No, like, if you walk on the, dot and line, it is the displacement, it is the shortest distance to reach the point B. So, whenever, if this is the shortest distance, then, you don't.
I'm saying, let us say situation. Okay, where you have path and you are able to pass on. You are able to pass on. Okay. So that is your distance. And you take it in the distance. Okay.
In that case,
In that case. So the difference is distance is something, it's called a scalar quantity. Do you know what a scalar quantity is? Magnitude. Okay. So displacement will be but it's called something vector quantity. Very good. So this is called scalar and this is called vector. Okay, we consider direction when it comes to displacement. Okay, fine. So there are a few different differences between this. This obviously it depends on your path, on the path that you travel. Does the displacement depend on the path? It does not depend, but it's independent. Displacement only cares about your initial position and your final position. See, displacement only cares about your initial and final position. Is that clear? Yeah. And the distance can you travel negative distance? That doesn't make sense, right? So distance is always a positive quantity. Okay, and the distance can never reduce with time. That's what is given. Yeah, and it cannot. Okay, fine. So, but displacement can be positive, negative, and zero. So the idea is that I'm considering the what? I'm considering direction. Okay. Why I consider direction? Now, for example, this is our you are in a place. These are north, south, these are east, and these are west. Okay. If some days are here and some days are here, or you just go or here, would direction matter? If you're here and you want to get to B, you want to go from A, you want to go to B, you're in a new city. You're in a new city, this is a map. So there you care about direction. You want to know what is your north, what is your south, what is your east, what is your west, right? And so similarly, when you're dealing with scientific things in science, when you're dealing with things on a smaller scale, we want to know in what direction exactly. Because if a lot of things come into the picture, okay? We can draw anything in terms of axis and all of that. And if something is here, it was moved here. I can tell with respect to x-axis, it was moved in the negative direction. And with respect to y-axis, also it is moved in the negative direction. You're getting my point, no? I'm not elaborating too much. I'm telling it quickly so you, assuming you're understanding. You're understanding all these things, right? Fine. All right. So, yeah. Okay, before we move into what is the time? Oh. So let's take a coordinate system. This is my x, this is my y, this is my z. Okay. So I have an object which is going from let's say it goes to a position A, it goes to a position B. What happened? 7:30. 2 minutes ago, I finished of the neuron. 2 minutes ago, finished off. Yeah. So what I can do is I can define this position of. Listen to this, watch this, and think about it. Okay. I can write, I can write something called a position vector. Okay. What did I say? Position. I'll write it as R dash of A. The cap, you see one arrow mark of the on top? Cap. It basically means, it basically means direction. That's all. It's not a scalar, it's a vector. That's when I put a arrow mark on top. Alright? Or you can put a, okay. I can write it in terms of X. It will have some value of X. 1. I cap plus Y1 J cap plus Z1. Are you able to understand this? Good. X1 is the particular magnitude that I have. I cap I Y E this has just been given like this, or here without explaining what it is, so I thought maybe very okay. Its whole purpose is to tell me that. Because if I have a quantity like this, if you just say 30, I want my direction, that direction. If you say 30 amount X. Okay. Clear? Note this one. Okay.
Anything with the cap, we got it in.
No, the I cap, right? One I cap is called a unit vector. That's unit. You multiply the unit vector into a particular quantity, it becomes the quantity. It's like east. Okay. 30 kilometers east. That is right. One east means nothing. For 1 kilometer, 30 kilometers from. Getting same thing you see, but it's also not different. So I I no, this will be quantity. It could be a constant, it cannot be a constant. If it is position, and the position is constant, X, Y, Z, B is constant, it's not right. As long as it's constant, X is X, Y is Z. Now, okay, position. Yeah. The thing is, yeah. What do you guys write on? Like this, you guys write R. I don't know how you write R. It's R. This is R. Refers to position of A and anything that direction. It's the direction point. Okay. Similarly, can you tell me what will be for RB X2 I cap? Okay, somebody else now. Plus Y2 J cap plus Z2 cap. Excellent. Okay. So now my displacement from AB, I'll write like this, okay, in direction. This means it's going from A to B, okay. So what will be my displacement? Can be write this down. What will come into the brackets?
The product of the
Product is displacement. What is displacement? I have two positions. Final position, initial position. What is displacement? Final position minus initial position. Simple, no? X2 minus x1, I get plus right that. Come. It's going to be x2 minus x1, I cap, y2 minus y1 j cap, and z2 minus z1 k cap. Is this much clear to you? So can I write my change in R as delta R? And what will this be? Can you please write it for all of them, delta whatever?
like delta whole delta.
No, delta refers to change in something. Delta, I can just write it as delta x, change in x, x2 minus x1. Delta x means change in x. What is the change in x? Delta x2 minus x1 is the change. That's all. Ananya, are you clear? I don't know. I'm not able to. Are you able to follow?
Yes, sir, it's clear.
Okay, okay, good. If you have any doubt, you let me know, Ananya, or you can put it up in the group, okay?
Okay, sir.
Fine.
So then
Yes.
R can refer to AB, sorry, R can refer to AB one. Is it related to that?
Yeah, it's
Yeah, that's what the vector is related to AB vector. Vector is about AB.
position. Yeah, we can write it. Yeah, but okay, you are able to understand that delta R cap and AB cap, they're the same thing, right? This is a different thing.
For problem like we got problems that way, it's multiplication.
So math we can get focus to cross and not
For this one,
in your this thing.
yeah.
Okay, okay. That is yet to be done, but I would like to take a look at your NCERT one. Okay. Fine. Cross and dot product you have it in your math, right? Okay, anyway, I think I'll check it out. Okay, Ananya, we will wind up for today. Okay, we'll continue in the next one. If you have any doubt, you can put it up in the group. Are you able to understand this?
Yes, sir.
Is the teaching fine?
Yes, sir.
Okay. Okay. See you in the next class. Then. Take care.
Thank you, sir.
Yes. Yeah. Okay. And then
I actually have to okay. You want to but it is not. The religion is the product, it is a religion of the no, that when you are lost flat. So from where it yeah, for the during the course class. Actually, they were not like whatever will be coming growth the prediction. The mathematically. Uh, so, that's why I Definitely, I will give a lot.